Alright, in this video I'm going to show you how to graph ellipses. Now, I took off all those characteristics on those previous graphs, like linear functions and uh, root functions and absolute value functions, all those other functions, because ellipse is not a function. So I took those characters away because I did want to show you how to manipulate these a little bit. So I'm going to start with a typical function of equation for ellipse. Again, it's not a function. So I'm going to write x squared over 4 plus y squared over 9 equal 1. And that's typically what an ellipse will look like. It'll have x squared in the numerator, and it'll have a number in the denominator underneath it. It always have a plus sign. They'll have a y squared over some number, and it always equals 1. So we always have an x squared, we always have a y squared, we always have a plus sign, we always have it 1. Alright. The easiest way to do this problem is match up the denominator with the numerator. Okay, underneath the x squared I have a number 4. So what I do is I take the square root of 4. Oh, before I do that, let me back up a second. Let's look at the x squared and y squared. Okay, that tells me that the center of this ellipse is 0, 0. Okay, so I'm going to put I should not put a point there. I'm going to put a little x at the origin, meaning 0, 0. Now, if it said something like this, which I'll do in a second, over some number, and y plus 3 squared over some number. Alright, then the center would equal the opposite of a negative 2 is a positive 2, and the opposite of positive 3 is a negative 3. So that's why the center of this is 0, 0, because there's nothing in that x squared group with the x, there's nothing grouped with the y. So I'll show that in another example in just a minute. So the center is 0, 0. And if you don't see anything with x, don't see anything with y, 0, 0. Alright, now let's pair. Underneath the x squared is a 4. I take the square root of 4 and get a 2. So that means since that's underneath the x, I go on the x-axis 2 units to the right of the center and 2 units to the left. So I'm going to put a point here at 2, 0. Okay, 2, 0. And I'm going to put a point also to the left 2 units from the center. So that'd be at negative 2, 0. And these are actually going to be 2 points on my ellipse. Alright, now underneath the y squared, I have a 9. So I'm going to do the square root of 9 and get a 3. So that means I go up and down on the y-axis at 3 units up, 3 units down. So I'd have a point here at 0, 3 and a point down here at 0, negative 3. And that's really all I need to find to basically graph my ellipse. Ellipse is a flattened circle. Okay, that's what I think of it as. Ellipse, I call that a flattened circle. So if you draw a circle and just kind of squeeze from either the sides, squeeze them together or squeeze the top and the bottom down, it'll be an ellipse. It looks maybe somewhat like a football. So let me sketch this. The ellipse would look approximately like this. Okay. Whereas the circle would look like this. Okay, that's what a circle would look like. So that black ellipse is really just kind of that red circle flattened out. So let me get rid of the circle. Okay, that's our ellipse. We have a center of 0, 0. Okay, we have what's called a major axis. Let me get these things out of the way. We have a center of 0, 0. We have what's called the major axis, okay, which is the y-axis, and it has a length of 6. That means the longer way across is 6. That's 6 units. Alright, if we have a major axis, we have a minor axis. What's the length of the minor axis? Well, from here to here, that's 4. Alright, and really we also can measure eccentricity, but I'm not going to measure that. I'll describe that today. It's just a measure of how flat an ellipse is. The foci, hopefully I'm pronouncing it right, I take the two denominators and I subtract them. Okay, so I'll put and I get a 5, and I do the square root of that. Alright, and then I go from my origin, from my center, along the major axis, okay, you don't use the minor axis. You go, you do the center plus that square root of 5, and you do the center and you go minus square root of 5. So you take the center and go to the right, square root of 5. Square root of 5 would be a little bit more than 2. Let's see, so it's the major axis, the y-axis, so my foci would be right about here where that black X is. So I start in the center, go up a little bit more than 2, the center, go down a little bit more than 2. Okay, so the coordinates of this foci at the bottom would be X is 0, Y is negative square root of 5. And up here at this other black X, the coordinates of the foci would be 0 and a positive square root of 5. Alright, let's try another example. Alright, in this ellipse, I'm going to actually have it so that the center is not the origin. So to do that, all I do is pick an X, and I just pick a number. Let's say we pick 3. Alright, squared on the outside. It's always a plus for an ellipse. And let's make the Y, let's pick another, let's say negative 1. Alright, I'm going to pick 2 numbers for my denominator, just for make it easier to graph. I'll pick 2 perfect squares, like I'll pick 25 and I'll pick 9. Okay, and ellipse always equals 1. Okay, so this is an ellipse. You got an x term squared over some number plus. Main thing is a plus. If it's not a plus, if it's a minus, it's actually not an ellipse, it's a hyperbola. It's a plus and it equals 1. Okay, so how do we graph this? First thing we need is a center. Okay, so just change that sign to -3. That's our x coordinate of our center. Change that to a positive 1. That'll be a y coordinate. So I go onto my grid and I go to -3, positive 1. Okay, and I'll put an X because this spot is actually not part of the ellipse. It's just the so-called center of it. We don't really have a center of an ellipse because the ellipse is not a circle. It's somewhat flattened. So from there, I say, well, let's see, underneath the X term I got a 25. I'm going to do the square root of 25, which is 5. So in the X direction, left and right, I go 5 points to the right and put a point, and 5 to the left. So from -3, 1, I go right 5, I get to a 2. When at -3, I go left 5, I should be at a -8. Okay, so those 2 red points are actually 2 points on my ellipse. Alright, now on the Y, underneath the Y, I see a 9. Square root of 9 is 3. So in the Y direction, I move up and down. I mean, Y direction is up and down. So from my center, I move up 3, and from my center, move down 3. And there's 4 good points on my ellipse. I just draw the curve as best we can. Kind of looks like a football, though it's not really pointed at the end. Alright, and that's our ellipse. Okay, what can we measure on our ellipse? Okay, the characteristics, the center, which we'd already talked about. Alright, the foci. Okay, I take my two denominators, which are 25 and 9, and I subtract them. And I get 25 minus 9, that's 16. I do the square root of 16, so this is going to really graph really well. So I see my foci is in 4 units from the center, and it's along what we call the major axis. I didn't write the major axis. The major axis length is from this point here to this point here, and that looks like it's 10. So I'll write major axis length. Alright, the minor axis goes to the center, but it's the shorter way across this ellipse. So I'll do a wavy line for that one. That has a length of 6. So to locate my foci, I use my major axis. Okay, this is the major axis. I'll do a purple wavy line. That's the major axis. Of course, right there is the center. I just go 4 units to the right and place a dot. Okay, so this would be one of my foci, that blue dot, and go from the center of the ellipse to the left. That's my other foci. So that's a foci, and that's 1, 1, not 1, 0. And this point right here is -7, 1. And these are our foci. And that's really the basics of what I wanted you to get from how to graph ellipses.